Hello everyone, welcome to the video solution for Edexcel IAL Physics Past Paper Solution. This is Summer 2018 Physics Unit 1. So let's start. Question number 1. Physical quantities are either scalar or vector. Select the row of the table which correctly identifies a scalar quantity and a vector quantity. So in this question, this is again a typical question recognizing the scalar and the vector quantities. It's better if you can memorize a list of vector and scalar quantity in your specification. So I'm just giving you, these are some of the quantities that they keep asking. So this is a column showing scalar quantities, and this is the vector quantity. If you can memorize this, it will give you a lot of help. And from this table you can clearly see that power, it is a scalar, this is in the right column. Work done, which is also a scalar, this column is wrong, so you cannot choose A. Velocity is a vector quantity, so due to this you can ignore B. C, weight is again a vector quantity, so wrong, so your last choice is D, but you can check that work done is a scalar quantity, so this is correct. Weight is a vector quantity, this is correct, so your option is D. Question number 2. The unit for the viscosity of a fluid may be expressed as Pascal second. Which of the following expresses Pascal second in SI base unit? SI base unit means you need to express a given unit in terms of SI, those 7 SI base quantities. Base unit, sorry about that, it's a base unit. So base unit is, if you remember, the kg, second, meter, mole, Kelvin, ampere, and candela. So you need to express Pascal second in terms of these 7. And how do we do that? So Pascal second is already a base unit. Pascal is a unit of pressure, so you can rewrite Pascal as Newton meter minus 2, and this second is here. Remember, Pascal is a pressure, so pressure is force per unit area. That's why you have a unit Newton meter minus 2. So again, this Newton can be written in the form of these SI base unit. Newton is kg, meter s minus 2, and m minus 2 from there, and this is the second. So if you simplify kg, meter and meter minus 2, so meter minus 1, second minus 2, and second plus 1, so second minus 1. This is equivalent SI base unit of Pascal second. That means C. Question number 3. A material undergoes significant plastic deformation under compression. Which of the following describe this material? Brittle, ductile, malleable, and tough. Okay, so they're talking about behavior. The behavior is, it is deforming. The key word here is a compression. So the material which deforms under compression is malleable. So we have option C. Remember, ductile is a material which is deformed under tension or tensile force, and If under compression, it is a malleable. Option C. Question number 4. The manufacturer of a car claims that the car can accelerate from rest to 30 meters per second minus 1 in 7.5 seconds. What is the average acceleration of the car over this time period? A straightforward question. You need to find average acceleration. An average acceleration formula is A equal to V minus U divided by T. And car is starting from rest. That means initial velocity is 0. So acceleration is 30 minus 0 divided by time 7.5, and the answer is 4. So your option is C. Question number 5. 3 spheres P, Q and R of the same mass are lifted from the ground and suspended from a rigid support as shown. Sphere P, Q and R, this is the ground level. The greatest change in gravitational potential energy is seen in spheres. Okay, so change in gravitational potential energy. So gravitational potential energy, if you are lifting something from ground level, this is some object of mass m and it is raised to the height h. If it reaches there, then the change in the potential energy in this interval is mgh. So gravitational potential energy depends on two factors, mass and the height. In this case, all the three spheres have same masses, but you can see that heights are different. So R is covering less height, but P and Q, if you see, they have a same height. So change in potential energy in P and Q will be same. So your option is B. Question number 6. The graph shows how the extension X of a spring varies with the applied force F. Select the expression for the expression that best describes the work done W in extending the spring. The general concept of force extension graph and the work done, if you have force on the y-axis, extension on the x-axis, and if you have a straight line like that, so area under this line is area A half Fx, which is energy stored, or work done. The concept in this formula is, if we need to find the area or if you need to find the work done or energy stored, remember, this is the key point. We need to say that the area under the graph and above the extension axis. In the given question, extension is given on the y-axis. So that means if we need to find the work done, so we need to see this area. Clearly, this area will be greater than half of Fx, because half of Fx is the area under the straight line above the extension axis. So your correct option is D. Question number 7. A displacement time graph for the motion of an object is shown. Displacement and time graph. Which of the following statement is correct? There is a decreasing resultant force acting on the object in the direction of the motion. So it cannot be option A, because although force is decreasing, but it doesn't mean that the speed is decreasing. So because force is decreasing and acting in the same direction, and it shows that we have a resultant force in the same direction of the motion, so this force will cause accelerated motion. That means velocity will be increasing, but the rate of increase in the velocity would be less as time passes. There is an increase in the resultant force acting on the object in the direction of the motion, so we expect the velocity of the object to be increased, so it cannot have B. There is a resultant force acting in the object opposite direction of the motion. Yes, opposite direction of the motion means if a resultant force acts in opposite direction of the motion, that causes deceleration, and the displacement time graph of decelerated motion is curved down. So this is decelerated motion due to some resultant force acting in opposite direction. So your option is C. Question number 8 and 9 refer to the information below. A box is placed on a table. The box and the table are both stationary. This is box, table, and the floor. The diagram shows the direction of the forces acting on the box and on the table. These are free body diagrams. This is the free body diagram for the box and free body diagram for the table. Question number 8. Which pair of forces are equal in magnitude according to Newton's first law? So your option A is Ft and Nb. So Ft is force of the box on the table, and Nb is force of the table on the box. Yes, these forces are equal, but if you see the statement, force of table on the box and force of box on the table, so they are equal due to Newton's third law, not due to Newton's first law. So we cannot choose A. B is Nt and Nb. Nt is force of the floor on the table, and Nb is force of the table on the box. Clearly, force of the floor on the table, Nt, must be greater than Nb. We cannot have B option. So for C, Wb and Nb, Wb is weight of the box and Nb is, yes, we have option C in this case. And you can think these two forces as, what if you remove table from under the box, then you can see the box is falling towards the floor or falling downward due to Wb. And if you put the table, then table is applying force in upward direction, which is Nb. So table is holding box. That means Wb and Nb are equal. So your option is C. Question number 9. Which pair of forces are equal in magnitude according to Newton's third law? I have already explained in the previous part. So this is the option A, Ft and Nb. So you can see that Ft, force of box on the table, force of box on the table, and table on the box. So your option is A. Question number 10. A student investigated Hooke's law using the equipment shown as each additional load was added. the new position of a marker along a meter rule was recorded and the extension calculated. Okay, so this is the extension is being recorded, weight hanging, and okay. The investigation was repeated with an additional identical spring arranged as shown. So now we are using two identical spring in parallel. For a given applied load, which of the following statement is correct? Remember, when springs are used in parallel, this parallel combination causes a spring constant K to be increased. And if springs are identical, then K is 2 times. So it's difficult to extend the combination of a spring combined in parallel because the stiffness is increased. So you need large amount of force. But so in this case, K is going to increase, stiffness would be double. So it will be difficult to extend. So the extension is double, which is correct. Sorry, the extension will be double. Now extension will not be double because stiffness is double and it's difficult to extend. So it is not A. The extension is double because the spring constant is half. No, because of half. The extension is halved because the spring constant is double. Yes, C is the option because stiffness is double, so extension is half. Question number 11. A small Okay, so a small stone is released at the surface of a lake. Immediately after it is released, the resultant downward force on the stone is 1.0 times 10 to the power minus 5 Newton. The stone initially accelerates through the water and then reaches a steady downward speed V as shown. Calculate V. Okay, so according to condition, they are saying immediately after release. That means as soon as you release this stone at the surface somewhere here, so in this case weight is acting down, W, and upthrust is acting upward, and at that moment you have a downward resultant force Fr at the start, at the beginning. That means in the beginning you can say that W minus U is equal to Fr, and then the stone is accelerating down. Suppose here the stone is reaching terminal velocity, and you know that as a stone is accelerating down, other than W and upthrust, an additional force starts acting, which is drag force, D, and this drag force keeps increasing until U plus D becomes equals to W. This is the condition when the stone reaches terminal velocity or the steady speed. And if you see from this equation, if you rearrange, so you can see that W minus U is equal to D at terminal velocity. And if you compare this equation with this, at terminal velocity, so drag is basically the amount of force required to balance the initial resultant force. So you can say that Fr equal to D. So Fr is equal to the drag force. And according to Stokes' law, drag force is 6 pi eta RV. So you can substitute the value. So Fr is the resultant force, which is 1.010 to the power minus 5 equals 6 into 3.142 times eta, and eta is viscosity of the water, which is 9.0 into 10 to the power minus 4 into r. R is the radius, and radius is half of the diameter. So half of the diameter, so 1.1 into 10 raised to the power minus 3 into V. Now you can make V as a subject. If you do that calculation, so V would be equal to 1.1 meter second minus 1. This is the terminal velocity. State one assumption made when calculating the answer to part A. So as you can see that we are using Stokes' law here, and Stokes' law is applied if we assume that the flow of the fluid is a streamline or a sphere is very small. So we can apply Stokes' law. So you can write any one of the option. So you can say that water flow is laminar and a stone is spherical and a small. If you wish, you can add a small sphere. Thanks for this video. See you next.